make short, ladies and gentlemen, with me is Gareth Heyes from UK, and he's going to tell you some awesome stuff about fuzzing and non-aplhanumeric JavaScript code. Enjoy, and give it a welcome.
Hi, everybody. Thank you. First of all, can I just say it's a real honour to be here, because in Germany there are very much, I consider the best place for researchers in security. Hello. I said thank you for inviting me here. I consider Germany one of the best places for security researchers, and I hope I can inspire you today, to be one of those people. I'm going to talk about non-alphanumeric code in JavaScript and PHP. And I'm also going to be talking about fuzzing as well. The talk is in two sections. The reason I'm doing two talks in one is because I often talk very fast, and I give a lot of information when I talk, and I cut out, there's hardly any information about history or anything like that, because I don't really deal with the background to things. I like to get into the meat and discuss the issues that I present. So, how did it begin? Yosuk Hasegawa posted to the Slackers message board some pretty awesome JavaScript. It was like JavaScript that just doesn't look like JavaScript. It was based on executing code without any alphanumeric characters. And he initially found a guy, I think somebody he knew in Japan, did some Ruby code that was similar to this. And inspired by that, he said, why can't we do that in JavaScript? And he posted this little snippet that was actually quite large. What happened later on, it reduced quite a lot into small sections, and there was different techniques found to make the stuff smaller, get window objects, all using non-alphanumeric code. So we're absolutely amazed the fact that this guy posted this, because it's not been discussed anywhere before. We're talking probably about 4 years ago, maybe 5 years ago. I can't quite remember. So how does it work? Because JavaScript's loosely typed, the objects themselves can be used to create strings. So true plus true equals 2. So true acts as the number 1. False acts as the number 0. So the key to using it is using string indexes. A string index in JavaScript is a non-standard feature that allows you to treat a string as an array, and the index specifies the letter. So you can convert the objects using the concatenation operator. So the object value will initiate the toString. So if you've got an object that returns object, like so, then you can reuse these string characters. So all you need from those values, you can reuse object and then the uppercase object. So you just need the actual numeric value, and then you just need the actual syntax to create an object. All without alphanumeric characters. So you need the number 1, and that's alphanumeric. So to get a number, because JavaScript's loosely typed, you can just use the infix operator and then just plus the array, and that becomes 0. So it returns a blank string when value of or toString is called, and because it's a blank string, when the plus operator is used before that, they become 0. To get the number 1, you can use a not operator, which just reverses the value, obviously. So you've got false and true. So if we want to get bigger numbers, how can we do that? Using object accessors, you can increment the values without a variable. This is quite a cool technique. So normally in JavaScript, you need a variable to increment or de-increment. But a guy from Slackers, or a girl from Slackers, I'm not quite sure, came up with this cool trick. If you're actually accessing a property of an object, you can actually increment it without actually referring to a variable, which is really cool because you can increment these values multiple times. And it works without specifying equals, which is another important point when dealing with non-alphanumeric code. So how it works is that the array is inside another array, and then the plus gets the 0 from the array, and then gets the first element of the object, which is an array. And then you can increment the array, so the 0, like I showed you before, will be incremented by 1 because you're accessing it as an object accessor. So if you try and do that, for example, that's illegal. You can't do that. But using it within that context, with an object accessor, then you can increment it. So it's converted to 0, and then you increment it by 1. So you can do that further and combine them together to get larger values. And this is useful because if you've got a large string that's been converted and you need to get the 9th element or the 6th element, then you can add them all together to get the value that you need. So Firefox 2, and this is how all this techniques work. You could call and return the window. So for example, sort will return the window. The reason this works is that you're giving the sort function a reference without the actual array. So indirectly what you're doing is you're calling the sort as the function itself, and it doesn't know which array it belongs to. So in the specification, the older specification, it says it should return the window object. Now it returns undefined, but it did return the window object. This still works with IE9, which is quite cool. If you can get a window, then you can start to call. Then you can start to call alert, eval, location. Reverse does the same thing. So you're removing this value of the array. So the other example there with sort will work as expected, because the 321 will sort the array and return it. But the previous value doesn't have the value, so it will return the window. So you need the window to call the different functions. So how do you generate sort? We need to generate the string sort, obviously, to get the reference to the window. So what you want to do, you want to call the sort value and return window, all without using any alphanumeric characters. So any ideas? False. Object, object. True. True. So it spells out sort. So we need the string index for each of the letters. For false, we need the third index starting from 0. Object, object requires 1, and so on. So we first generate false using the technique I showed you before. Then we generate none. So we get the first elements of the array instead of concatenating. Enclose the array with the first element gets us first string false. So we're generating the values false and true, etc., and getting the values from them. So in the first example, I'm getting false, and then I'm getting the actual value from the array false. Then I'm converting it to a string, so now I've got f. So you need to increment the values to get, I showed you before, to get the other parts of the string. So So using our string false, we can get the third element, which is s, like that. So the first part's where I showed you how to increment before from the trick from the guy from Slackers, or the girl from Slackers. You can increment the values and get the third element, which is s, all without using equals. So like, if you wanted or, then you just need the object, and then you can get or. So yeah, access the first element of the array. And it's quite a nice shortcut to get or. So the same techniques can be applied to get the diff using the true. And that's sort. So there we go. That's how you get window. So you're combining all those techniques to generate the string sort. You're then calling the function that I showed you before using the technique I showed you before. And then once that function is called, it will then return window. So then, if you want to go further, how would you call specific functions like alert? So you need to generate the letters, obviously. We've got some some of the letters from before. So we can get an A doing that from false. L from false again. E. Combine it together. Alert 1. Just like that. So to execute arbitrary JavaScript is a little more trickier because certain letters are outside of what you can generate alone using the various objects. So, for example, you're limited to the fact that JavaScript will only return object, object, or true, or false. What about the other letters that you don't have access to? So generating every single character is hard work and impossible in certain situations. But using eval, or function in JavaScript, you can generate an octal escape. What's interesting about that is that all you need to generate a character is numeric values. So what you can do is generate all the numeric values, combine them together. So, for example, A looks like that in octal. So notice we double backslash escape the value there because we want it to return the character A. So what we need to do, we need to generate the 141. We need to put the backslash in, and we need to generate return. Once you do that, then you can basically return any string, any letter, from using the function call. So the conversion, so it'll convert the first part is you've got to generate function. The second part is you've got to generate return. And the third part is you've got to generate the numbers to generate the octal escape. And then you need a reference to window. And using that technique, you can generate any type of JavaScript code. And I'll show you some demos on how you do that. The great character wall was invented, I don't know who it was exactly, but it was discussions between Mario, myself, Eduardo Velo, and David Lindsay, I think. And basically what we tried to find out was how many characters are required to generate non-alphanumeric code that executes. We came up with the value of 6 characters. I think it was Eduardo Vela, that's his nickname. We tried many, many times. It's an addictive problem. I want each of you to attempt to do it. And there's plenty of resources on Slackers that will show you how, and the background, and the techniques behind all this that I'm discussing today. It's worth looking into why you can't do it. It basically comes down to a P and an underscore. Because there's a catch-22 situation in JavaScript where you can't generate an underscore And even now, the reason that you needed an underscore is that you needed parent. Because in Firefox, parent returns a window of any object. But they've removed that now. And P, you need P to get a certain function. I can't remember which now. So you need the parenthesis to call functions, and you need the object accessor characters to get the actual string indexes. And you need the plus to concat the values together. So you need all these characters for specific reasons. Removing any one of those characters will not work. So the actual 6 limiter characters is the absolute limit and cannot be broken. And I challenge you to find a way. So we attempted. We attempted quite a lot of times, and it drove me crazy. The reason it drove me crazy was I want to find a way to do something that nobody else can do. And I get a great joy of finding a way, a technique to do that, just because it gives me a kick to say, wow, you can do that. But this problem drove me insane, and I've spent many message board posts trying to figure a way to do it, and people just said, no, there's no chance, there's no chance. And they were right, unfortunately. And these are the reasons why. Parent on older browsers. I'll give you a demo. So I'm using my tool, Hackerpraktikum. I've put in alert 1. And this is using Yosuke Hasegawa's JJ encode. There were various versions done, but his function is quite cool, so I'm using that. And there you go. So we've converted our alert 1, or I'll execute it so you know it works as well. There you go. So we've converted our alert 1 into non-alphanumeric code, and you can see that the compression ratio, or well, the opposite, should I say, is quite large. So for the small amount of JavaScript that you put in, you're going to get a large amount of JavaScript out. Now, what's interesting about the actual conversion itself is that you need some certain parameters in order for it to work. So you need to get a certain amount of values. You need numeric values. You need to call function or eval. So it'd be quite an interesting side project, if anybody was interested, to try and map out the actual limit of arbitrary JavaScript generation in non-alphanumeric code. And it could be analyzed in the first part of the script, which generates the various letters like function. So, how do you decode non-alphanumeric code? It's quite tricky. The properties are not unknown, so you don't know the value until it's been run. It's like a catch-22 situation. You don't know the object accessor value until all the rest of the code has been run before. So you could be working on true, you could be working on 2, you could be working on a string. You don't know the value until it's been calculated by JavaScript. And by the time it's been calculated by JavaScript, it's too late, it's already been run. So how do you decode it using all that information? So here I demonstrate, so you don't know what X is until the script runs. So how would you do it? You could convert basic patterns. So you could look at to see what creates 0, what creates 1. But there's so many combinations in JavaScript to do that. So you could actually encode hex escape, octal escape, and then non-alphanumeric code generate as well. So it becomes an impossible task to actually go through each part of the code and decode it. Somebody tried to do it, which there was quite a cool decoder that took the basic elements of non-alphanumeric code and then converted values such as that to 0. But it was not the correct way to do it, because any slight modification to the existing rules would break it. So how can you decode it? So we need to sandbox a JavaScript code. The only way to actually, in my opinion, to decode the actual code itself is to run it and to safely run it. So we need to make sure that any function calls, like eval or function, are disabled, and things like document.write and document.body.innerHTML, etc. So we need to make sure that this code runs, but it runs to our rules. It's like we're creating a matrix, what we decide what they can do. A matrix world in JavaScript where they can only do this certain thing, and there's no other rules that they can do. Or they think they're opening a door in JavaScript, but really we control the door. So function. In order to generate non-alphanumeric code, you need function. If you change function, then you can listen to the actual function itself and see what it returns. So the code runs as normal, but when you call function, the actual JavaScript code doesn't call it, it proxies the function call. And instead of executing the value, it returns a string in our sandbox. So I'll show you a demo how to do that, and then I'll talk on the techniques behind it. So, as you can see, we'll reuse the code that I just done. So I'm using a function that I created, which is decode JJ encode. So what happens is the code is returned into a string. So I'm taking control of the function itself, and I'm deciding it shall return the value that's specified. And if you look at the actual function itself, it doesn't actually execute the code, but it returns the string value. So if I wanted to find out what that returned, then I'd simply call the function that was decoded, and then it'd give me the result. But should we do that a few more times? Three. Right. So we're calling this Yosek Hasegawa's code 3 times. So basically what we're doing, we convert it to non-alphanumeric code, and then we convert the non-alphanumeric code to non-alphanumeric code, and then we convert the non-alphanumeric code into more non-alphanumeric code, which, will it execute? Please? It'll either execute or my machine will crash or run out of battery. Ah, Hackerpraktikum user over there. There you go. So I did it twice. My machine's running on low on battery, but anyway. So we've encoded JJ encode once, and we've encoded it again. And you can see all the backslashes everywhere, and the code is quite a mess. But now we want to decode it. How do you decode it? Well, it's easy. We just run the decoder again. And then this time we're getting non-alphanumeric code out. Because it was once non-alphanumeric code, and then it encoded it again to more non-alphanumeric code. So we want the result. So calling the function returns a string. So that's the first pass of non-alphanumeric code. So let's run it again. JJ decode, and then let's execute it. And there you have it, alert 1. So as long as we control the function itself, no matter how many times you encode it, no matter what you use, eval, whatever, you can always get the result back. So how it works. So I developed a sandbox called JSReg, and it's under free BSD license, which means it's completely free. You can sell it on eBay if you want, I think. I don't care. But anyway, what it basically does is it converts JavaScript into a safe form of JavaScript and then protects it and allows you to proxy the functions like I mentioned before. So, for example, I've defined a magic property in the window itself called sandbox. And this is the process it does. So the whole thing that I showed you before to decode non-alphanumeric code is based on these lines of code. So let me just explain what it does. So we're creating a global object called sandbox. We're creating a function, we pass the code to the sandbox. The JSReg creates an instance of the JSReg sandbox to reuse to execute the code. We instruct JSReg not to actually execute eval or function, and instead we take away part of the protection of JSReg there and then return the result. So what we're doing is hijacking function and saying you're not having it, and it will return this. So we wrap it in a try and catch, and then it'll return it. And it's as simple as that. Those few lines of code will use a sandbox and decode the non-alphanumeric code. So we're extending the actual environment itself. So we're removing the unneeded sandboxing code is the specific protection in function calls where JSReg changes every single function and makes sure that it only executes a certain amount of times. I remove that just for visual purposes, so you don't see it, but then you can return the code as it was intended. And then it does the rest. So, how can we fool the decoder? So, if you can detect you're in a sandbox environment, so if you know you're in the matrix, then you can figure out ways to get around it. You could break the sandbox. You can find a syntax quirk in the actual sandbox itself. You could use a different function, or a DOM property maybe. How can you defend against that? So we could hijack anything that we wanted. We could change eval. We could change function. We could provide a fake DOM object that the actual attacker thinks is real. So they think they've got documents, they think they've got body, but in fact they haven't. Just got a blank JavaScript object. And the best part about this is that I challenge people, and in their free time, I'm not paying these people to do it, but I just challenge some awesome security researchers, and they will try and break the sandbox, just because it's a challenge for them to do. And it's awesome that people do that. I myself do that as well. So you can make the actual environment itself seem like it's the browser environment by changing all the toString value of calls in the environment itself. So I think like if you look at the toString value, it will return native toString as it would in the browser. So my challenge to you is, can you break it? Have a go. Just do a search online, JSReg, try and break it. And if you do, I'll do a blog post. I'll email you. I'll be your best friend. Question is, do you think non-alphanumeric code is evil? I bet you antivirus vendors will think it's evil. But I don't think that you can provide adequate defenses without testing what is possible. if an attacker can invent a technique that produces non-alphanumeric code, then they're going to do it. And if the defender doesn't know the techniques to prevent against that technique, then they're going to lose out. So get there first before the attacker does it. It's as simple as that. The attackers are quicker though than vendors that provide defenses, and they need to change that. It improves everything. It improves the tools. It improves the techniques. You'll find out things that you didn't know about before, all by testing the boundaries of something. So I thought JavaScript's cool, but why not PHP? You can do this in PHP? What? So I wanted to evaluate this stuff in PHP. Initially, I thought it was impossible, and nobody else tried. Well, they might have tried, but I think they all failed. So, because the problem is that PHP itself lacks the same sort of two-string value of JavaScript that performs automatically. So if you wanted an object to have a two-string value or a value of value in PHP, then you sort of have to use the syntax correctly and get that value. And without that, how can you generate it? So how can you generate characters from nothing? So I don't know why I was thinking about it. I was probably stuck on a work project, and I thought, I know, why can't I do this in PHP? So then I thought, in PHP, an array is converted to a string. So we can use the characters array. So each of those characters we can reuse. But what can you call with that? It's pretty limited, really, isn't it? Just those letters, you can't really call an eval. So how do you generate the code using those letters? So you can do bitwise operations on strings themselves in PHP. I think I've stumbled upon this on Stack Overflow, or maybe on the PHP manual, I can't remember which. So doing a bitwise operation on A and B can return C. How can you generate underscore? Underscore is important because get, there's a value in PHP called get, which returns the get form variable. So you need underscore in order to get that, so that you can pass data to PHP and execute it. So we can generate D using previous operations. So here's the process. Let's create an array, concat itself to the string. So we convert the array to a string of characters that says array, all without alphanumeric characters. Do a loop, XOR that string, and then a second loop with another value. So what you're basically doing is you're creating a for loop, finding the values that A creates, finding the values that A and R create, and then combining them all together in a three-step process. So here we create an array. So you concat using the dot in PHP concats variables together. So we're concatenating it with itself, which will produce the string array. Using the plus converts it to 0. So here we get the character A from the string. So we've got array, and we're using plus plus, incrementing it and getting A. Like that. So we XOR A with OX7F. What is that? Delete, is it? I don't know. Something like that. So OX7F, and then Yeah, it's a literal character. So I've displayed it in hex, but you have to actually put the character in the code. And PHP's fine with that, by the way. He'll just execute and think, no, it's all right. So I thought I was really clever, quite pleased with myself. And I was thinking, yes, I've finally worked it out. And I boasted on Twitter, and yeah. And then Stefan Esser, I'm sure, have you heard of him? Anybody with PHP? Anybody who does PHP and security will have heard of him. He maintains the Sohozin patch in PHP. And he said, why not use plus plus, minus minus, increment, de-increment? So it works on strings. I didn't have a C background, I think that's my problem. So this works in C as well. So you can have the string A and then increment it to B. So generating underscore, like all that process that I did to generate underscore was pretty much pointless because you can just increment the values and get the values that you want. But it was fun. So let's call hello. So similar to the JavaScript techniques, we generate the numbers that we need. I think, if I remember rightly, I used assert in PHP because it's obscure. Assert in PHP actually performs an eval and calls it. So I used assert because it's just more complicated that way. I don't know why, I think. So, as I said, you generate the letters and the numbers required. Yeah, assert. So assert is the same as eval in PHP. So that PHP has a character function, which is similar to the technique I displayed in JavaScript, but instead of using octal escapes, we're using the char function in PHP. So we need to generate the CHR. We need to generate CHR, and we need to generate assert, and we need to generate the numbers, and then we can create the encoder. And I'll give you a demo. What shall I say? Hello. There we go. And that generates hello. So I'll actually prove that to you if I Well, it's echoing hello. I knew something would go wrong, but anyway. Actually, let's fix it. There you go. Hello. And that's the end of my first slides on non-alphanumeric code. If you'd like any questions, we save that till the end of the second one. I've done 2 talks because I talk fast. So my next topic is changing the fuzzing world with Shazzer. So I want to revolutionize the fuzzing world because I think we're doing it wrong. I think that the current process of randomizing characters, executing them and thinking, hey, it's going to crash. Will it crash? No, it won't. Let's run it again. I think that's a bad process to do. And I think we can make that better, basically. So I needed a way to fuzz and store my results. Doing a fuzz test on multiple browsers that you don't have installed, that you need a VM for, that you don't know where to get Fox 2 unless it's from a dodgy site. How can you do that? I don't have Firefox 2 installed, do you? I don't think so. I needed to automate it and modernize. How can you take these browsers, test them, and return the results? Crowdsource it. So I don't want to do that. Let's get you to do it, or let's get you to do it, or let's get you want me to run your code and generate something. Why do everything on your own when the whole internet's out there that can share the problem with you? So what does Shazzer mean? Basically, I put shared and fuzzer together and got rid of the other characters, and it created Shazzer. The missus wanted me to call it by her name, because Shazzer is like a nickname for Sharon, but anyway. So we create a fuzz vector, and you share it with the world. So what we're trying to do is, we want to take a vector of fuzzing and boil it down to just the bare bones of it. So we want to use fuzzing in a way that you use XSS vectors, for example. We want to automate this. So we want to detect the browser, we want to allow somebody else to use it, and we want to store the results. So this is what we sort of do now. There's like various ways of doing it. I based it on what I did originally. What Shazzer is probably based on some of the code that I developed. So you can log the results to a text area. This is purely based on behavior-based fuzzing. So if you wanted to find out what character is allowed after an attribute, before an attribute, then you would create a simple JavaScript test that basically looped through all the characters, generated the characters, then logged to the text area itself. You'd have to test each individual browser, install them in VMs, I don't know, I couldn't actually test every single browser because it was just too much of a pain to do that. And then you might store it in a database, log file, text area, whatever. It's a pretty messy way to do it. It's hard to visualize the data too. One of the problems with behavioral-based fuzzing is that how do you show that data? So if this attribute allows these characters before it, what do? Do you just put them all in there? What if it's a new line? How do you display that? It's quite hard work. So it's slow. Testing every character set is slow as well. If you've got UTF-8, if you've got Shift-JIS or whatever it's called, or the Japanese character sets, it's going to take you a long time to go through all that. Operating systems can also affect the actual characters that are allowed to execute in different circumstances. So a Japanese user in a specific character set on a Japanese version of the OS will get different results than somebody in America running their language. So it's hard work to test. And you might not think of a way to do something, but somebody in the US, somebody in the UK might have thought, I know, this is how you do it. So how does it work? So we detect each browser on the fuzzing client itself. The user creates a vector. So you create a vector as you would an XSS vector. So you can share this vector with anybody in the world, and they can run that. Or you can make it private if it's sensitive in any way, which is a lesson I learnt when developing it. So fuzzing works without, you don't have to log in for each browser, because if you did, that would be a pain. So we need to separate the fuzzing method to execute without having the requirements of logging in. Because if you can imagine, if you're having to test 10 browsers and you've got to log each one of them in, it would take a long time, slow you down. So it's an authless fuzzing system. Obviously, that's got disadvantages as well that you can probably imagine. So the fuzzing client itself generates the characters in 10,000 character intervals. The reason I chose 10,000 characters was based on my own testing. I found that 10,000 characters performed better. It also limits the memory overhead on my own server, which obviously I don't want to exceed. So here's an example how to create a fuzz vector. This specific example is an XSS-based example, but you can apply these techniques to other areas, which I'll leave to your imagination. But basically, it works in placeholder ways. So the star CHR is the character, and the star number, num, is the number, the character number. So basically what you're saying is, do a for loop of all these character sets, do a for loop of all these characters, and with these placeholders, replace these values with what we're fuzzing for. So you're automating the browser part, you're automating the character generation part, and you're automating the actual 10,000 loops per character, per interval. And so what happens is the placeholders generate the numbers. So we can use a simple question, which you can answer in Shazzer. Which characters close a HTML comment? Shazzer can answer. So the character placeholder is there, and the num placeholder is there. So I'll give you a demo. Okay, so the first part of it is to give your vector a descriptive name. So I'll give you an example. Characters that execute as HTML elements. The keywords are assigned to give your vector searchable information about. So you could place keywords that are related to the vector but aren't specified in the description. The preparation code itself executes before your vector actually executes. So it allows you to, for example, if something doesn't execute in JavaScript, like CSS, then you need to check that beforehand. So the preparation code allows you to look at the fuzz data itself and then check the values and then send the results. So the preparation code does the logging for you. So the complete function, for example, runs when the window completes loading, and then the inbuilt variables like doc mode. So you've got the IE doc mode, because in IE you can have various values. You can have 5, 6, 7, emulate 7, 8, 9, edge 10. There's so many doc modes in IE that it's so difficult to test. So what Shazzer does is allows you to do this. It puts this information in there for you, and then logs the results using XHR post value. I use post because I execute all the vectors and then send all that information when they've completed for speed purposes. So your vector is constructed below. So we're mutating the character basically, and the character number. Doing this via the DOM using document.write or init HTML is slow, very slow. So we're using PHP, and it generates the actual values by the current interval. So we're going to say, I want the characters from 0 to 10,000 to generate using this vector. So we continue fuzzing until 100,000 characters, and every character set has been fuzzed. So we're going from 0 to 100,000 in 10,000 intervals, and every character set, and every browser that has been tested, and every IE doc mode. So there's a couple of security risks. So, for example, if you create a vector while it's fuzzing, and then backdoor that with malicious code, how do you protect against it? It's very difficult. So I could say, I've created this cool vector. It'll tell you any characters that execute before an attribute. You run this fuzzing code, and then you decide, well, I'll do a cross-site request forgery to Facebook, and you won't even know about it. Malicious code as well. People could backdoor it with malicious code. You could use the actual vectors for search engine, evil search engine optimization, link back to the SEO. This is the kind of stuff I think about when developing it. You can fill it with useless data. There's no way I can stop that. That's one of the downsides. Probably something you've probably all identified when I was talking about it. But you could log from 0 to 100,000 and log it all and fill it with rubbish, basically. There's no way that you can prevent that. But what you can do is make the vector private, delete it, redo it, verify the results, which will come later. So what I do is I don't allow the vectors to be modified. You can fork the vector itself, so you can copy it and do it again, give it a different name. So the idea is that before you run this vector, you should check that it doesn't contain a Chrome 0-day, IE 0-day. It posts pictures to your Facebook account, etc., etc. If they're using a security tool, I would expect people to know this. I had some requests saying, why can't you fuzz all the vectors? The reason for it, obviously, is that people can backdoor these vectors and do evil stuff with it. You're creating, in effect, a botnet, and giving people control over changing that is not a good idea. So I separate the domain for fuzzing, because I can't, basically, I need to execute this code. I need to execute as it would in the browser. There is no other way to do it. So I separate the domain and I execute the code. So no robots on the fuzzing domain to prevent the search engine evil stuff. In private vectors. So you can create vectors that aren't public. These are useful because you might have stumbled upon a technique that isn't public. You don't want it to be public. You want to test it first. You can still fuzz the private vector by using the randomized key that it provides. So if you're on IM and you want to share this vector with your mate, but you don't want to tell the world about it, you can send them a link, allow them to fuzz it for you on their browser, and it will still work. I've just said that. So we need to view the results in a meaningful way so that you know what your vector has achieved. We need to view the results by the specific browser and all browsers. But what we can do is that we can find differences in behavior. So one good example of this that was found by somebody on Twitter, but I can't quite remember the name now, but they used Conqueror on Linux, and they found that in an anchor, Conqueror allowed different characters that weren't allowed in any other character. So Shazzer's got an option where you just press diff. You press diff, and then it will find these behavioral differences. So what I'm saying basically is that IE does this, Firefox does this, but Conqueror does this. So it's new behavior. So what you're defining is browser quirks, something that non-standard or something that's different that is interesting because you can use it to bypass things like filters. It could even end up causing a crash or whatever. So we can automatically generate the POC, the proof of concept. So the actual vector itself is reused and then generated, and then you can just verify that it works. We can improve Google. We can make fuzzing answer questions on Google. So I want to know which characters close a HTML comment. So, the third link on Google gives a listing of that. Shared data, if you share your fuzzing data, it will improve external sites. It will improve your tools. It will improve the entire web. We can do tests based on behavior of browsers. They can all be automated. They can all be, Shazzer allows you to export as JSON, so you can know the various browser quirks, the various behavior. So, characters that close a HTML comment. Third link, click it. There they are. So what we're doing is basically improving search engines, improving tools, answering questions, and getting useful information out of it. If I just tell you, oh God. So quickly, if I just tell you, the characters defined here are a null, an exclamation mark, a hyphen, and a greater than sign. In HTML5, you'll notice that because of the rendering engine, I don't know why, but they decided that to close a HTML comment, you could use an exclamation mark. Shazzer shows you that information. I'll quickly demo it. I don't know if my battery's going to last. So we can view by all browsers or by an individual browser. And we can view this behavior. I'll quickly try and show you. So we've got a listing of characters allowed before a JavaScript function. If we click diff, and my battery doesn't run out. Come on. It will get you specific browser behavior that doesn't happen in other browsers. So with this information, we can mutate the existing vectors and create new stuff. We can find out which browser allows the most stuff that doesn't work in other browsers. We can cross-reference that with all the behavior in the new versions. So if a new version comes out, we can test that against all the previous data that we have and find out if there's any regressions or anything like that. We can build cheat sheets automatically. So we can build vectors automatically. We can build stuff that crashes, that executes JavaScript, that is undefined CSS behavior. We can build all this automatically. Example of data, these are the browsers scanned. So Chrome, Firefox IE, Opera and Safari, 4,000 in Chrome, 6,000 odd in Firefox, 6,000 in IE, 5,000 in Opera, Safari, etc. And these are the actual right. It will return the results. I think there was something like 60,000 in Chrome. So we can use the scan data and compare it against the results data, and then we can determine which browser is allowing the most stuff. Maybe Firefox brought out a new HTML parser. How effective is that? How insecure is that? Using Shazzer, you can find out that information. The future direction of this is, like Wolfram Alpha has like a computation engine that allows you to do math equations, etc. Using this fuzzing data, we can do that with security. So we can answer questions that normally would take you time to find out by yourself, to work that information out. We can also enumerate data. So we can provide vectors with a way to enumerate HTML attributes, HTML elements, values. We we might decide to put null values in a HTML element length attribute property and see if a browser crashes. But more interestingly than a crash, you can verify that the browser does not crash. So by generating a data enumeration across a lot of data, thank you. So we know the browser is scanned. This data is just values. So all I've done is done a simple SQL query to get the values scanned. Shazzer knows the values scanned, and it doesn't look at the actual vectors themselves. So this data isn't reliable in 100% because it can't be verified. But this gives you an amount of browsers scanned and then the amount of characters logs. So this amount of values in Chrome, where's Chrome? Can't see it. Oh, Chromium, yeah. Oh, top one there. 63,000 characters were logged in Chrome. Firefox, 20,000 characters. IE, 49,000. Safari, 71,000 characters. It might give you an indicator that Safari, there's something not quite right in a character set, maybe. Yeah, but it can give you useful information like that. This is only the tip of the iceberg. So we can export the data via JSON. The JSON structure itself will include the vectors and the actual placeholders to allow you to reuse this data. So you can easily reuse it with external tools. So it's good for creating an XSS reverser, for instance. In case you don't know what a reverser is, basically you just send a lot of data to a filter, inspect the result, and try and reverse the actual output of the filter to determine how it's filtering data. Now, if you can do that based on the knowledge you've gained in fuzzing, for example, what characters are allowed before an attribute, then you can use your XSS reverser to determine if this filter is good or not. So you can automate the process of testing a filter. So I use PHP for it. The only reason is I don't really care what your language I use, but I've done PHP and I'm comfortable with it. I know its issues. I know its good points and bad points. I use JavaScript to control the fuzzer. The JavaScript itself is extremely basic, and all it does is basically there's an iframe that calls another iframe that allows you to schedule the sections together. I use prepared statements, of course, because I don't want SQL injection. So the process I do is I whitelist my filtering first. So I make sure that all my data is whitelisted. So a description of the vector will be whitelisted. It will HTML escaped after that. I use type hinting for numeric data and to force strings because PHP allows you to specify a get variable as an array, which I don't want to happen in certain instances when you're calling a regular expression on it. So security holes. What security holes were in Shazzer? The register ID was not stored correctly. Simple typo. I didn't store the user ID in the session, so it resulted in 0. The wildcat on Twitter found that, and he told me, obviously nice disclosure, he didn't publicly disclose it, but it didn't really have any impact apart from the fact that a new user couldn't create a vector. The reason why this didn't have any impact is, I believe, the process that I used. So what I'm trying to say here is never assume that the data is safe. So you always check a session variable, even though you assume that you've set it to the correct value. So a user ID, for instance, would be the insert ID of the users table. But if that didn't happen, you need to verify that that didn't happen. And that's basically the lesson I learned. So another instance was that Mario requested that I allow certain characters in the description of a vector. what happened was that my whitelist filtering got disabled because some of the characters caused a regex error and then was disabled and didn't actually perform the whitelisting that I intended. The HTML escaping mitigated that problem though, because I HTML escaped that afterwards. Even though my whitelisting went kaput, it didn't matter because the vectors still displayed. They weren't that useful because the whitelisting was there for a reason and prevented it from executing. But because I did a two-step process of filtering and escaping, it didn't cause a problem. So the lessons that I learned here are just make sure that you've got a valid regex, and make sure that the user data is not mistyped, and verify that. So future plans for Shazzer. So we can use advanced mutation. The problem you've got with one character mutation is solved in Shazzer. But when you've got two characters, it gets to a lot of data. We can crowdsource this problem to make it possible, whereas on your own it wouldn't be possible. Because if you can imagine, you can have a vector that specifies one character and the next character, and and you could have 3 mutations, 4 mutations, 5 mutations. So we can use data enumeration as well. So we can enumerate HTML and attributes. We can use Boolean vectors so we can determine browser behavior. So if there's a question on Twitter that said, can you determine which browser supports what feature, etc. You could solve all those questions. So you can have a common list of values that cause problems, and then share that information with the world. Another interesting area that I was looking at is self-modifying and mutating code. So what you want to be able to do is basically make the code come alive itself, and then try and get the code to generate its own vectors, which is a lot harder than it sounds, because there's a simple for loop, for instance, would probably cause a denial of service, because it wouldn't know whether the operator should be used in the correct instance. And a computation engine, so that we could answer questions about security and get answers, which we can't at the moment. The methods that we're using currently, I don't think are sufficient, and hopefully my plans are to change that. Thank you. I'd like to thank Josek Hasagawa, Stefan Esser, Mari Heinrich, Eduardo Vela, Lever One off the Slackers Forums, Thormaker, Ronald, Exor, Nick, SW, Wildcat, Harmony Guy, and all the other people who have made this talk possible. Any questions? Thank you.